Last year, hundreds of refugees drowned while fleeing to Greece across the Mediterranean. We are making a mobile application which will display simple animated instructions via a tablet connected to a robotic boat. This visual communication will help rescue workers better ensure that the refugees make it to shore safely. Hi, my name is Catherine and I'm with Team To Be Determined. I'm here to introduce GiveHub, our new application that will help rescue workers involved with the refugee crisis in Europe. War and turmoil in the Middle East have caused an influx of immigrants from Syria, Turkey, and nearby regions across national boundaries. In particular, many of these immigrants flee to Greece. Their journey across the open sea is anything but safe, and hundreds never make it to shore. This is a tragedy. Fortunately, the refugees are not alone. The Red Cross and other non governmental organizations are working together to help. Their efforts involve spotting incoming refugee boats, steering them towards safer places on the coastline, and providing food, water, blankets, and other aid to them once they have landed. As part of these efforts, the NGOs employ an Emily lifeguard robot in cooperation with Dr. Robin Murphy from the Texas A&M Center for Robot Assisted Search and Rescue. Our project is a direct result of this partnership. Now that we've looked at the motivations for this project, let's identify the specific problems that we'll be addressing. The rescue workers face several challenges. Specifically, these include the language barrier between rescue workers and refugees. Both the NGOs and the refugees come from many different nations, and there is no one common language. The rescue workers are separated from the refugees by distance across the sea. The Emily vessels are currently used to close this distance, but its capabilities are limited. The refugees often have no prior boating experience at all. We set out to address these problems with the following solutions. To help rescue workers overcome the language barriers they face, we would provide them with a means of using visual communication that could be understood regardless of native languages. Since the Emily vessel can already close the gap between rescue workers and refugee boats, we decided to equip Emily with an Android tablet that could be controlled over a local area network. In order to manage the refugees' lack of experience, we will provide them with simple animated instructions that show them what they need to do next. These solutions were combined into a single Android application, GiveHub. GiveHub aims to provide users with an easy-to-use interface that allows wireless transmission of visual messages. These can be used to relay easily understood instructions, which should help improve the refugees' chance of survival. For the next few minutes, we'll go on a guided tour of GiveHub and we'll see how it works, inside and out. Before a single line of code was written, a lot of planning took place. We designed the algorithms and decided on data structures and other important technical details. In particular, we laid out the specifics of how the client-server communication would work, as well as the internal file system, navigation, and storage. Additionally, we created mock-ups of a user interface that evolved over time, making use of the native Android design features. This in-depth planning method of writing the code before writing the code helped the development process to go smoothly. Much of our planning was invested in time management. Taking a divide and conquer strategy allowed us to make use of a Gantt chart. Breaking the project up into parts that could later be assembled together allowed us to divide the work between our team members. This way, we were able to all work together without any one person being overburdened or becoming too tightly coupled in one area. Budgeting our time for the development stages was critical. Our financial budget was easily managed. We were able to complete development entirely using university-provided equipment, which meant our financial budget was zero. Our planning helped us to identify a series of user acceptance tests that we could use to determine if our finished product was a success. A typical user should be able to complete the following tasks while using the app. Connect 2 Android devices wirelessly over a local area network, add animations to the app from the device's internal storage, play animations from within the app, stop an animation that is currently playing, and navigate the user interface without external assistance. We're happy to announce that we were able to successfully complete each of our user acceptance tests. Let's take a look. To add an animation, the user opens the app and hits the Add button in the top right. This allows them to navigate through their device's internal file storage to locate and upload the desired GIF file. Once they have added the animation, they can see it listed in the list view within the app. Once the desired animations are added, they'll need to connect to another device that they want to send animations to. They'll start by pressing the Connect button to view a list of available devices to connect to. After selecting one, they now see that they have an established connection. On the other device, which is also running the app, the user can also see that a connection has been made. When the user selects an animation from the list, GitHub transmits the file name and location to another device, which can then find the file in its own internal storage to display the animation. From this same screen, users can stop the current animation or select a new one. In the case that a user wants to delete an animation, they can simply press and hold on the animation name within the list view. This prompts the user to confirm if they want to delete it, following standard Android development conventions. Our application had a high success rate during the user acceptance testing phase. With minimal instruction, the users were able to complete each of the tasks as given. By definition, completion of the user acceptance test validates our application as successfully fulfilling its initial goals. Now that we've seen that GitHub works as it was designed to, we can imagine how it will be used in the real-world scenarios it was intended for. Here we'll see a rescue operator using GitHub to send instructions to refugees, which they can see on the display attached to the Emily vessel in the water. After seeing the instructions that the rescue operator sent them, the refugees were able to follow the directions, which will help increase their chance of survival. That's GitHub. That's how we address the problems that the rescue workers in Greece were having and package the solutions together into one application. After identifying the end user's needs, we planned, developed, and tested our app, resulting in a simple yet effective and useful tool. We hope that GitHub will make a valuable contribution to those it was designed for. As with any new product, there are a number of ways the application could be improved. For example, extending the app to be iOS compatible, allowing two-way communication, and transmitting complete files over the network are all great ideas. It's not hard to imagine that this app could be used in domains outside of refugee work, such as a form of instant messaging. From the beginning, our focus has been to help the rescue workers in Greece, and that focus guided us to finish our product. The refugee crisis in Europe is a perfect example of a way that computing and software can be used to aid in disasters and crises around the world. Our application was designed and developed to help humanitarian relief efforts overcome the obstacles they face today. Now those same obstacles will be less of a challenge thanks to GitHub.